Hi everyone. Today we are going to talk about how can we use LLM for research. With us, we have Arka and Deshan. To give a brief introduction about ourselves, I myself, Pranjal, is currently doing my PhD in computer science from Swansea University. I am in my second year of my PhD, working on how to retrieve information from the experts. Now I will love to invite Arka to introduce himself, and then we will move to Deshan. Arka, up to
Hi everyone, I'm Arka Majhi. So I'm a PhD student in Sitara department in IIT Bombay in India. So my research is on training healthcare workers through smartphone games, like Android games. So today we are together. We'll be discussing on the uses of LLMs in academics. So along with us, we have Deshan who will be demonstrating us. So to Deshan. You can introduce yourself.
Okay, thank you so much. I'm Deshan Sumanathilaka. So I'm also a PhD student at Swansea University, mainly focusing on computer ambiguity. And I'm currently working with large language models as well, how we can do sort of like prompt tuning, then how we can implement track pipelines, then how we can do the fine tuning of all these commercial and basically open source LLMs. So those are the areas what I'm currently working. So today discussion will be seeing how we can come up with a small application in order to chat with the conference paper or a journal paper, and how we can use GPT 3.5 turbo model as our base model, and how we can do a simple query to get sort of some data from our papers. So this is going to be the discussion for today. Pranjal?
Thank you, Deshan. Now let's kickstart. As Deshan mentioned that we are going to do some query with the LLM. Nowadays, we all know that LLM has come into the picture. So how can we be more smart with the AI rather than misusing LLM or AI? Our intention in this video is to understand how to become more smart, how to reflect, how to develop critical thinking using AI. So Deshan has selected two papers, what we are going to use today. Over to you, Deshan.
Okay, Pranjal. So the main thing before jumping into this application, I'll just give you a quick discussion about what is these large language models. So large language models are basically, we could say, a sort of a branch coming from AI, artificial intelligence. So this LLM came into picture with the introduction of this attention is all you need paper. So after that, we know there was a quite a bit. Got a lot of improvements over all the neural networks and architectures, basically introduced transformers, right? So after 2019, the transformers came into picture. Then there was a quite a lot of improvement in this area. So there are quite a lot of we could say open source LLMs and commercial LLMs. So open source LLMs are freely available where you can use fine tune and you can work with open source LLMs. In commercial LLMs, we normally don't get a chance to see the source code, but still we can use some sort of API keys, and we could prompt and do our task. Even models like GPT, they allow us to fine tune from our data. So this sort of like new trends over to the LLM has been a good trend, because like we can use LLM for different tasks like text summarization, question answering, then basically identifying the sentiment analysis, all those things, all of these actions can be done basically using LLMs. So this is mainly focusing on text. We know we are having multimodal systems where all images even can be handled using large language models currently. Like so OpenAI are mainly working with all these particular areas, not only OpenAI, but Google as well and Mistral. All these companies are working on enhancement of these particular models. So what we mainly going to focus is like how we can use these models as our base models for our day-to-day works. Yes, Pranjal.
Thank you, Deshan. So as I have been trained in design research, that means I sit at the intersection of computer science, psychology, design. So I have this question where I want to understand, why do you call it LLM? Why do you call it large language model in AI?
Yeah, this like there's a particularly something which is like language models. Like basically, language model came into the picture first. Then we know we are having huge tons of data. So basically, what most of the researchers trend try to produce was like how we can come up with a particular model for large amount of data. So basically, there were some sort of characteristic. Mainly, they were focusing on how a huge number of data can be trained, then how huge number of parameters can we think of when we are training the models. So this large word came in front of the language model was because of the enormous data what we have in this particular model. So all these base modules are trained on data. Basically, we say it's as unsupervised training. So all these data are not properly labeled, but all these base models are trained over a huge amount of data, huge amount of parameters, where they are capable of doing the next word prediction. All these base models, mainly all these large language models, are good in next word prediction. That's why we might have heard some word called hallucination. So whenever some of the prompting, when we ever do prompting, we get some sort of answers, but which are not existing, because all these base models are much more good in next word prediction, or we could say sentence or text generation. So now what these particular companies, what they have done is they have fine-tuned this particular base model in order to do their task. Example, ChatGPT is one of a task. So what ChatGPT does, it take the base model, which is like a GPT base model, where they even say Da Vinci as their base model. Then they have fed a lot of instruction over the instruction data, where sort of like conversational data, so that it has been fine-tuned, where we have the GPT 3.5, GPT-4. So that this GPT 3.5 turbo LLM model, GPT-4 models are now capable of doing a sort of like a conversation. So whenever we do a sort of a conversational sort of like a prompting, they are much capable of doing that because they have been fine-tuned over the conversational data. So obviously we are having a base data, or we could say base model, where the data where the huge number of, or the enormous number of data has been fine-tuned. Then, or we could say trained, then it has been fine-tuned over different sort of data in a different sort of area. That's why we can see we are having a huge number of varieties on different LLMs, where they have been fine-tuned over different data which is in a one particular domain. I hope this is clear.
Yeah, thank you. Later on, once you start, would love to understand what do you mean by Da Vinci base model, and
Yeah.
especially you have been talking about fine tuning.
Yeah.
So up to you if you wish to tell us what does fine tuning mean, or later in the video,
Yeah,
wherever you think is.
I'll give a quick understanding about what is fine tuning also. Like when we are working with large language models, we are having some important three words what we discuss. One is prompting and prompt tuning. So mostly all these language models, we query with prompting. So then there is some technique called prompt tuning, where you try to tune the prompt. So prompting is a art. Obviously, prompting is going to be an art. The way you prompt, the way you say something to the model. So it has to be sort of like a practice. So based on the practice, you gain that uh, art. So how to do a proper prompting. So there are like so much of what you call courses what you can do over how to do a prompting. So we have a now new avenue where we say as prompt engineering. So how we can enhance the prompting. So likewise, based on the prompt tuning, we can always get a better answer from a model. Because when we ask general question, so whatever the answers what we get from all these language models are in general. When we make it specific, when we tune the prompt, so we say that step by step, so do this thing, do that thing, then why don't you do this thing also? You can generate more answers, so you give a length. So you make your prompt much specific. So this is one thing where you do the prompt tuning. Then the second thing that we known as RAG, retrieval augmented generation, where uh, we will be giving some sort of content in order to understand to the model. So the model start learning over the content. Then we retrieve the data, or we could say we retrieve the answers for the prompting. So the major difference between now RAG or the RAG and the fine tuning will be, we don't need to fine tune the model, or we don't go and train again the base models in a RAG pipeline. Here what happen, whenever we are having a query, we try to retrieve the similar factors what we want to fed to the model, so that we fed the prompt along with the relevant context to the base model. So the model is start reasoning. So model is start learning on the content what we have provided. Then based on the prompt, we get the response. So then the implementation, right, it is very easy. We could say it's sort of like easy task. Then even we don't need to worry about fine tuning process, because we know fine tuning process takes a huge lot of time. Then it costs a lot of time. It cost time wise, it cost. Then the monetary value, money wise, it cost. Then fine tuning process is basically like you take the data what you want to train, then you make it as to a format. So basically, if you are training GPT 3.5 Turbo, or if you are training GPT 4, they have given their own format, but you have to create your data into a format, sort of like chat agent based chatting format, where you should say this is the question and this is the expected answer. So you create it into a JSON format, then you fine tune the model. Then once you fine tune the model, the major advantage what you get, so you are fine tuned, you are done with the fine tune. So whenever you need to query, you start querying. So you don't need to pass any sort of extra data, or you don't need to do the retrieval. Instead of that, what you do, you take the fine tune model, then you start querying. So that's a great advantage in a one aspect, because though you are spending sort of time over the fine tuning, so once you are done, so you can freely what you call query with related to the particular domain what you have trained on. So this is a great advantage when you do the fine tuning, but the initial cost is little high. It's a matter of tokens.
Thank you. If there's anything, Arka, you could ask, or shall we go into the demonstration?
Right. I think the academicians or the students, like current students who are watching this video, I think there's a lot there's a lot of things in your basket you can learn from this
True, very
video,
true.
like the ways use AI in your day-to-day things, like let's say literature review, writing good papers,
Correct.
finding meaningful insights. So, for example, reading papers was a thing. Now we are used to listening to papers. Now the next
Correct.
paradigm shift which we is interpreting papers through AI, like using the bots to understand papers. So I think I'm really interested and I'm really excited for the new wave of proliferation of the knowledge which is going to happen in a very exponential way. And as a result, the speed and the efficiency we will be in academic writing and overall academics to say. So, yeah, Deshan, can you demonstrate us or show us
Yeah.
some like tools in which we can do it?
Yeah, true. So this is a simple application what I have created by using GPT 3.5 Turbo model as the base model. So this is basically done with an RAG pipeline. So I'm using some sort of data where I have to feed the data into the model. Then only we are going to do the query. So I will quickly have a look on some sort of instances how you can query. Then I'll show you the basic pipeline behind this particular scenario, right? So I'm going to upload one particular document. So I'm going to initially upload one technical paper, which was authored by me, which is known as Sobasha. So this paper is based on sort of a transliteration. So I'll quickly give you an idea about this paper. This is related to Romanized Sinhala to Sinhala transliteration. So which is a reverse transliterator, which you can use with ad hoc translators, where you can even use shorthand typing. So this paper is mainly discussing about how a particular system can be developed to handle the ad hoc transliteration on Romanized Sinhala and Sinhala. Sinhala is a language which is mainly spoken by Sri Lankans. So we mainly focused on coming up with a proper model in order to do the ad hoc transliteration. So this process continue with multiple approaches. So there are sort of phases what we have followed. So there is like a data collection approach, then data analysis is available, then data annotation, then identifying the rules, rule generation, then data set creation, then feeding the n-gram model, then having an rule-based model. All these hybrid model has been used in order to come up with a proper solution. So this is the paper what I have already uploaded to the model. So initially, when you upload the model or upload the paper into the model, there are some actions what is happening in the backend. So I'll come up with that part later. So now the paper is being uploaded. So there are some actions happening in the backend. So now what we are going to do is we are going to do a simple query and see how the model start generating the answers, right? So what is going to be the first question? So we'll ask what is this paper is about? What is this paper is about? So now what happens? So whenever you click on ask, so the prompt is generally passed to our backend. So then it start retrieving the data from our PDF. Then the retrieved data along with the prompt will be sent to the LLM or to the GPT 3.5. Then GPT start reasoning with the data what the model received and the prompt, then only the answers will be generated. So now it says what is this paper is about. Now it's giving a wonderful answer. The paper is about hybrid approach to transliteration from Romanized singular to singular. So the basic idea of this paper is doing the transliteration on Romanized singular to singular. It says it combines n-gram model, rules-based model with a knowledge base with a trie structure to handle the formal and informal handwrite Romanized singular transliteration and word ambiguity, which is a wonderful answer. So it is basically handling the formal words as well as the informal words. So we could see it says how the evaluation has been taken place, then what sort of a methodology has been used. So this is a particular answer what we got from the chat along with the prompt what we have given along with the context. Yes, Arka, we can go ahead.
So to more tone it down for the viewers, so it is
Okay.
a combination of the general intelligence of ChatGPT and combining the knowledge we provide through this paper by uploading this paper to the model. So
Yeah,
it is
correct. So,
combining this knowledge and kind of trying to answer you based on like the best of both this knowledge.
correct.
So
So
it's really interesting in academics to use this kind of a tool in which you combine all of the papers which you have. Like for example, you are doing a literature review of let's say 10 papers.
yeah,
Now we can only combine one paper at a time, but
yeah.
future, I mean, there will be a possibility in which we can upload our entire literature review and we can query the like whatever has done in the past, what we can be seeing in the future, and what is the current knowledge or the current state of the art techniques we can use in this current theme. So I think
Yes,
this approach will be very helpful for academicians overall.
yes, Arka. So I'll add one point to this. So as of now, in this user interface, you can see only one particular file is getting uploaded. So this can be further fine-tuned, or we can say this code can be further enhanced such that we can upload a bulk of PDFs. That is totally possible. So when you upload the bulk PDFs, so what it start to capture the content what we have in the PDFs. Then it creates chunks, right? So if I quickly go to the workflow, this is basically happening in our backend. So whenever we give the papers, so this can be 1, this can be 10, this can be 100. So it doesn't matter, right? So basically what we do, we start uploading our papers, then we load it into a directory. So this is like, even if you want to scrape, if the papers are obviously available to download freely, then you can scrape all this data. Then what you do, initially you take the data and you chunk it. So that means you take the text data, whatever in the PDF, you take out the text, then you chunk it. So this chunking, we can decide what is going to be the chunk size and what is going to be our overlap, right? So we can avoid missing our data when we are doing a sort of a prompting. So basically in this case, I'm keeping the chunk size as 1000. So that means all the chunks what we have created will be chunks of 1000 tokens. So that means you take all the data, you chunk it. So that means based on this, based on the size of the paper, it will generate some amount of chunks. Then what we do, we take all these chunks and we use an embedding model. So here I'm using a BG small English embedding model, and there are some other well known embedding models, like even recently OpenAI releases a particular embedding model which is quite a good model. Even OpenAI is having a small model and a large model, like, as I can remember. Then there are like BG large model. Then likewise, there are multiple embedding models. So what we do here, whatever the text data we are having, or whatever the chunks we are having with the text, we transform into a numerical format. So we know all the models can understand numerical values rather than the text. So we convert into an embedding. So then these embeddings are stored in the vector store. So here I'm using the files as a vector store. There are some other vector stores available, like ChromaDB, then Pipcorn. Likewise, you can even test on those things. So there are some vector stores which they provide a huge sort of functionalities among them. Example, if you go ahead with Pipecon, so even Pipecon has this ability of doing the semantic similarity rather than doing the simple cosine similarity and retrieving the data. So here you can see I store all the data into a vector store, then only we start the retrieving process. So they basically that means you take all your data, you pre-process. So this total task. So in this pipeline, this total task, you set up all your data what you require for the query. So you are having a sort of like a database. I could say it's not a database, but it's a vector store where it store all the vectors related to a chunk, related to a chunk. Then only when we do the prompting, we retrieve the data. So we can send all which is similar data to the model, so that along with the prompt, you can get the solution. That's why we can see we are getting some sort of data with respect to the data what we have given. As Arka mentioned, that's correct. When we are doing the solution, or when we are doing the response generation, obviously the base model knowledge will be used, because the results generation will be done by the LLM, because it's used the data what we are feeding, the prompt what we are feeding along with their knowledge. So it try to generate the data, or it try to generate the response by using GPT 3.5 turbo model along with the data what we have provided, along with the prompt, as well as along with the knowledge what the business model contain. Yes, Pranjal.
Thank you for that. So going to the chunk part, when we are splitting the data. So
Yeah.
in the computer science perspective, what does chunking means? As you also mentioned that you have decided here in the model to have 100,000 tokens.
Yes.
So what does chunking means in computer science, and what is 1,000 tokens?
Yeah, it's sort of like this. Now we know we are having a one sort of a limitation with all these large language models. The thing is, we are having input token size, like whatever the tokens, or whatever how many tokens we can fed into a model at a one go, because prompting matters a lot for us, because there is a one particular length a particular model can handle at a one go. So there is a token limitation. So what we do here, now it's always better if you can send the total PDF as a one go to the model, but it's not possible when it comes to the token size. So to avoid that thing, what we do, we try to tokenize into different sectors. Or chunking into the different sectors, so that all these tokens came to chunks. So chunks are getting stored. So whenever we do the prompting, we retrieve the most relevant data from our vector store and we'll be passing. Example, now we'll think in our paper, normally we are having a particular structure, right? We will be basically writing an abstract, then we'll be writing an introduction, then we are writing a literature review, then we will be having a methodology, then we will be having sort of a results and a discussion, then we'll be writing all the conclusion, future works, likewise. So what happens when we do the chunking? So abstract related data will be chunked. Introduction will be chunked. Then the methodology will be chunked. Then what you call results will be chunked. So then whenever we ask a query, whenever we do a query, then related to the query, the most appropriate chunks will be retrieved from our vector DB. So now we'll think we are querying something related to the abstract. Then obviously we should get the data with respect to the abstract, not with respect to the other knowledge what we want, right? So it's a matter of like playing. So we need to play with the chunk size. So you like when you play with the chunk size only, you will identify what is the exact chunk size you need to think about based on the scenario. So now we are discussing about with a conference paper. So if we are having a paper with huge number of what you call we'll think pages, we'll think 100,000. So even for those things it should work, right? So then based on the scenario or the based on the way the papers or the way based on the way the PDF has been arranged, you can decide what can be the chunk size, how the chunking need to be done. So it's a chunk mean it is a sort of like you have a sort of sentences as a particular now document. Now you divide all your text data into different documents. It's think like this. Your PDF is being splitted into documents. Like if you are, we'll think you are having 10,000 tokens in your PDF. Now you are chunking it to thousands. Now you are having sort of like 10 documents. So now whenever you query, you retrieve most related documents and you pass it to the model. So the model doesn't learn unrelevant data. It's always retrieving the most important data to us. I hope this is clear.
Right. And what do you mean by 1,000 tokens? So you're
Yeah,
saying how many chunks should be made?
yeah, this thousand is a number. Thousand is just a number. It's like how many tokens will be available in one particular document. So that means when you chunk it, each chunk is sort of like a document. So whenever you give a number like 1,000, each chunk will contain 1,000 tokens, right?
1,000 tokens. Got it. And if in the analogy of the paper, what is
Yeah.
token? So for example, you're saying one abstract is one chunk. What would be the token? Token would be the
Yeah. No,
words.
no. Like tokens mean like we obviously do a tokenization, like it like tokens, like we cannot say token is a word. Token is a basic unit, how you split or how you understand particular text. So token can be a text, token can be a character even. So it's a sort of a format where how you do the tokenization, right? So one sentence, like we'll think you are having a 5-word sentence, it can have 5 tokens or even it can have many, more than 5 also. So that is totally based on the way you tokenize it. So here 1,000 mean you take the abstract. So we'll think in your abstract you are having 2,000 tokens, right? So basically 2,000 tokens, if you take chunks as 1,000, then what happens? You will be having 2 documents, which is like in your first 1,000 tokens will be in a one chunk, second 1,000 tokens it will be in a one chunk. So whenever you do the query, so it retrieve the most relevant data to us.
Sure. Thank you.
Yes, Arka, you can go ahead.
Right. So token is like the basic unit of the computation
Correct.
we are trying to do. So
Yeah,
just like
correct.
the body has cells learned in biology, so tokens are the most basic unit of computation the model need to perform in order
Correct.
to generate something.
So even in large language models or even in any neural network or any model, the base we say it's the base of any sort of mainly when we are working with text, we could see the token word come into the picture. This is the most general basic factor what we have to think of. So you do the tokenization, then only you all do all the processes for ahead.
Yeah, sure.
So can we go back to the
Yeah.
outline? So we'll ask some more questions. So this paper explain some. So we'll ask some sort of data like what sort of hybrid model, what hybrid model this paper use. So here now what we do, we are querying. So it says the paper uses a hybrid model, consists of n-gram model, a rule-based model for the reverse transliteration, and a knowledge-based model. So the knowledge-based model mainly used for the try structure, which is for the suggestion. So likewise, you can query. So if you are having any sort of query, we can ask.
So can we basically ask what is n-gram model?
Yeah, we can ask what is n-gram model. Yeah, this is very interesting. So here now you can see it is giving the n-gram model is a type of probabilistic language model used in the natural language processing in the computer linguistics. It predicts the probability of the word given in the previous n-1 words of the sequence of words. So now if you have a look on the paper, it doesn't explain about n-gram model. So it doesn't explain something about probabilistic language model. It doesn't say, it doesn't give an deep meaning on the n-gram model, but you can still see an answer. So now I could think we can answer to the question of Arka, whether this is using the base model knowledge. Yeah, this is a solution coming from the base model knowledge. So though we pass some sort of context, so the best solution for the n-gram model is given from our base model. So now if we ask like, what is the n-gram model? We'll ask what is based on the context provided, based on the context provided, what is n-gram model? See, now we can see it's combined. It's giving the results combined. So the first one says n-gram model is a type of probabilistic language model used in the natural language processing. So this is from the base knowledge. Then it says the content provided. In the context provided, the n-gram model was implemented using NLKTK unigram tagger, trigram tagger, and the trigram tagger with a backoff. So this is coming from our the context what we have provided. So it's a matter of like how you do the prompting. So you need to do the fine tuning always over the prompting. So how specific your prompt, so it will give you the appropriate answer to you.
What if we write the question based on the paper, or from the paper, tell me what is n-gram model? Will the answer remain the same?
Like now what we have given is based on the context provided. So we have asked just to provide the context. Based on the context also provide. So it's sort of like how the model generate the response. So always it use both the context what we provide and the base knowledge as well.
So that, yeah, first Arka, then I will ask.
Right. So viewers, I want to. Okay, sorry. Viewers, I want to say that here, like let's talk about the use case. Like how can academicians use this kind of tool? So for example, if you are kind of referring some paper from the literature and you want to quote something, you want to quote some definitions, you want to quote some findings. So it's a very good way to extract those findings, like, and also like you won't be plagiarizing that part. So in this way, the language model is generating uh, a new text for you, right? Based on your query. So, I mean, this kind of practice would be good. And okay, like it's not a shortcut, I will say, but if we use it responsibly, it can be a good tool for the academicians to retrieve knowledge and use it in their own paper.
Right. Yes. So I have a question in this. The way you have written the prompt.
Okay.
So you are using the word based on the context provided.
Yeah.
If as a because I believe you have been using prompting for a long time and you know how to do the prompting.
Hmm.
For first instance, as a novice user of how to do the prompt, how to write a prompt, I would have written based on the paper, tell me what is n-gram model. So does the answer changes? Is context is related to what the chat GPT understand? Is there a difference how which word we use?
You can try doing it as well.
Yeah, like initially we did, like now you can see it says based on the context provided. So now we can see the answer has been generated also on the context as well. So it says what is the particular what you call the taggers what it has been used. So basically it has also trigram, a unigram, bigram, and the trigram taggers. So now if we make it more general, so we don't say anything about the context, we are asking what is n-gram model, right? So we see the response. Now you can see now the answer is given as the n-gram model is statistical model used in natural language processing and machine translation. It predicts the probability of a word based on the previous n-1 words in the sequence of model. The model is commonly used tasks like speech recognition, machine translation, and text generation. Now this is not giving us the content what we searching in our paper. So that's why doing a sort of a tuning over the prompt will retrieve the exact data what you want from the paper. So it's a matter of playing over the prompt.
So if you write another question,
Mhm.
based on the paper provided, what is n-gram model? If you write that.
Yeah, we have already query, I guess, based on
Instead
the
of the instead of the word context, write paper.
okay.
What
Provided
is
what
an
is n-gram model. We'll ask like this, but the thing is like the model will always see a context, because model, like when we are sending the data, model will always see it as a context. So rather than a paper, we are not passing a direct paper to the model. So we pass the chunks, right? So I don't think it will uh, impact a huge, but it will generate your answer. We'll see. So it says now based on the information provided in the paper, the n-gram model is a type of language model used in the translation. It is mentioned that the n-gram model use combination of rule base, and it says the n-gram model implementation was done using NLTK tagger, bigram, trigram, and n-gram model is used rule base is used to handle the translation. Blah blah blah. Yeah. Now here what you can see, it has been removed the what you call the general interpretation what has been given, that is totally based on the way we do the prompting,
and is
right?
this known as prompt tuning, or prompt tuning
This
is
is
something
prompt
else?
tuning. Yeah, this is prompt tuning. We tune the prompt. We always change the prompt and see how we can tune it.
So which one you say is better? Is this prompt better, or the previous prompt was better where you were using the word context?
For the both the scenarios, we got the similar sort of answers, because in this scenario, I have kept the temperature. So mostly in our next discussion, we'll be discussing about the way how we implement the this particular application. So here there is a one factor called temperature. So if we give the temperature as like 0.5 value or 0.6 value, the creativity of the model increases. So you won't get the same answer for the all the prompt. Like even though the prompt looks similar, if the temperature is 0, it will be generating as the same answer. But whenever we keep the temperature as a high value, it always try to become so creative. So you will not get the same answer for same question again and again, right? So we could improve the what you call creativity also by using the temperature.
Right. Thank you.
So shall we upload the other file also?
Yeah.
So I'm uploading the other file, which is related to uh, the ins and outs of HCI for development. So, so initially you can see it takes some time to process. This is because of the initial task of chunking and converting into embeddings and storing in the vector store. Yes, Arka.
So I think the viewers are able to grasp the thing we are trying to discuss. Also, the link to these papers will be in the description. So you can also, and also the access to this tool will be also in the description. So in the next video, on the next part of the video, we'll be describing how to make your own LLM similar to this, where you can actually input your own paper and try your hands out. So on that note, so I think the paper is uploaded. We can try some prompting.
Yeah. We'll first ask what is this paper is about. It says the paper appears to be about exploring the field of human-computer interaction for development. So this paper is mainly focusing on HCI for development, with focusing on designing technology and interfaces for users in developing countries. So it explains some of the context about research paper trends and approaching on HCI 4D. So this is a particular solution what is generated by the this paper. Yes, Pranjal.
So as a novice who do not know how to write a prompt,
Hmm.
I is there a way that I should learn how to do the prompting, or I I have been reading research paper and that LLM has come into the picture, which helps me to do more thing what I could do in a much faster way. So how should I train myself, or how should I learn how to do the prompting? Any suggestion? What does prompt means?
Yeah,
Or yeah.
it's a matter of like the way the like once you start prompting about a particular thing, you get it to know like whenever your prompt become general, you get the solution as general. So in prompting, when you are getting experience on prompting, what we normally do, we try to be more specific. What we want, we specifically mention. This is the thing what we want. So if we ask like give it in point forms. So I'll update this. What is the paper is about? Uh, Give the answers in point form. Right. So now you can see this has been given as point. So this is marked as a with a one hyphen. So the first thing the paper discusses about significance of the impact of human computer interaction for development. In the second point, it highlights the key paper in the CI 4D field, including the review, summarize, and the seminal work. So then whatever the way the answer produced, you can utilize it and further enhance. So it's a matter of like how you want it. So like when we discuss about prompting, there are like different technologies actually, right? So we say one is like single prompting, then we say few shot prompting, then we are having something called chain of thoughts. Like there are like different way how you do the prompting. So now in these particular things, as of now, all in all the case scenarios, what I use was like sort of a zero shot prompting. We are having just the prompt. So when it come to few shot prompting, we are giving a prompt with some examples. Example, we'll think in generally we'll think about a large language model where we say we are giving a sentence and ask categorize this whether it is a happy or a sad. So that is zero shot. We don't give any sort of an example. But when it comes to see technique like few shot prompting, we say like, okay, there is a sentence, I'm going to church and I'm happy. So, or we could say uh, I was happy on seeing something. Then we say that try to identify the sentiment based on the given sentence. And we say, please refer to these particular examples. So we say, we give some sort of instance, like we give, if this particular sentence is happy, we say the class need to be happy. If we are giving a second sentence, this class need to be sad. We give one more thing, we say it's neutral. Likewise, we show some sort of examples to the model along with what we want to query. It's sort of like few shot prompting. So we give some examples along with our prompting. So there are ways how we can do the prompting. Whether it is zero shot prompting or whether it is few shot prompting. It's a matter of like how you do the art of prompting. Always being specific, you get the specific solutions. Yes, Arka. Arka, you are on mute.
Right. So sorry for that. So for the viewers, let's dive into some hands-on querying things. I mean, out of this paper. For example, uh, one of my favorite authors here is Indrani Medhi. So now I want I can always do a control F and find what has the author contributed to this paper. But let's do it on the LLM way. So we
Okay.
can prompt that, okay, what is the contribution of that author in this paper? So let's see, okay, let's talk about what we can expect out of this LLM first. So
Okay.
will it give a general answer, based on the knowledge, based on all the corpus it has on ChatGPT, or will it only stick to this paper? So it will be very interesting to understand that. So what is
Yeah,
the
we'll
contribution of,
yeah.
yeah,
So
Indrani?
we'll type it and see. Is it Indrani Medhi, right?
Right.
So we'll.
No, so we need to ask that in this paper, or uh,
So according to the context given, Indrani Medhi's contribution is in this designing mobile interface for novice and low literacy users, as mentioned in the context. So this is giving the solution using the context provided.
mhm.
So we could.
Why why is it not using general intelligence or the base model intelligence to answer this thing?
Uh, yeah, it's a matter of whether the base model has been trained over the data with related to Indrani Medhi. That's one concern. So because I don't know whether GPT models are trained over the literature. So I think the user specific, more user specific things are not much captured on GPT. So whenever we are provided with the data and when the data is available about an particular author, then obviously it will be giving the solution from the context what we have provided. So
So
if we could
can we force it to ask some questions out of this paper,
out
just in
of
case,
yeah, we'll try without
right?
considering the context provided. Text provided. Give some contributions done by
The author,
she's the author, right?
all right, THIES,
THIES.
right? So the thing was okay, so the concern was can I use it as a kind of a Googling as well? With querying the paper, can I ask general questions also? That was what I
Uh,
was trying to understand. Because it
like
will be a very versatile tool for academics if it can do both uh, on the same way. Like while reading a paper, if I get to know about some author and interested about that author, so
hmm.
can the general model give me some, uh, you know, like literature about that author as
Yeah,
well? So
that's
that is
possible. That's possible if we could integrate one more section to query with related only to the knowledge based on the GPT model. Now, in this scenario, we pass a sort of a data along with that. So if we could simply check about on only the GPT without the RAG pipeline. So in the RAG pipeline, we send the data along with the what you call data along with the query, right? So, but we could test. So I'm having a general code what I have written for querying the GPT. So we'll simply see without using a RAG pipeline how this particular model can give the answer. So this is purely on GPT without providing any sort of a data. So we'll ask what are the contributions? What are the contributions of Indrani. Yes, for HCI, isn't it?
Mhm. This paper or for HCI would be or
Yeah, this is enough,
something.
right?
Right.
So are you asking about the author or are you asking about the paper?
No, I'm asking
About
about
the
the author.
contributions.
Author, which so this the author is Neha Kumar.
No,
No,
this
no,
is
no,
like
not of the
general
author, of
general
the
prompting.
related
Okay.
authors. Related
Yeah,
authors.
like this is now
Okay,
this
so
now
now I
whatever
think
this
it is going from general intelligence.
correct. This is exactly from the general intelligence because we are not in this particular code. I haven't provided any sort of extra knowledge. So this is totally on prompting
Right.
on GPT 3.5 turbo based model. So you can see Indrani Mehdi, this is a prominent research known as contribution to the field of computer interaction, specifically focusing on technology design for underserved communities. And it has given us some points. Co-found Digital Green, non-profit organization that aims to empower smaller holder. Likewise, it is given us a good explanation.
Right.
So this is from the base model. So when we implement the RAG pipeline, what happened? It try to see some sort of data related to this particular author in the provided context. Then only it is getting retrieved from the context and giving us back. Right?
Right. So the best case scenario would be if we like if in one tool if we could combine both of these. I mean, if it could give generic answer as well as the specific answers we are
Correct.
trying
Correct.
to find.
Yeah. Like
Also,
no.
no hard feelings for in Indrani if you are watching this. We are only trying to, like use it as a prompt. And yeah, great fan of your research and your writing.
Yeah, now why RAG is mostly important whenever you don't have a specific data on our base models. So then only RAG come into the picture. If all the data what we required is already like if it is like a general sort of data which what we need to query, then implementing a RAG pipeline is not required if the data is already available. But if we are having sort of like specific scenarios, if we have a specific sort of data what we want to query, then the RAG pipeline will work. Right? Yes, Pranjal.
So as a research, it is always told to us that whenever we are writing something, we should always give source of it. But the
Hmm.
challenge with the current LLM is, as you're saying, that general intelligence or REC pipeline,
Hmm.
they could also search it if it has been trained on other data. So how do how should we look at when we do not get from where it is picking up? But we need to cite that thing from where we are picking up when we are writing a research paper or anything in terms of academics.
Hmm. Uh, Normally, when we retrieve the data, we can retrieve the metadata. Normally, in this scenario, I haven't think of that approach. Normally, when you retrieve the data, if I guess I will able to show you some instance. Yeah, so this is some sort of like a metadata when we retrieve the data. So this data shows uh, from which particular paper I'm printing here docs. So there are some sort of metadata, but we can see whenever we do the extraction of the data. So we can obviously use those metadata also along with the prompt. We could obviously ask from the model itself. We can fine tune it and fine tune our code segment and say that send us or we can print what sort of documents we have used in order to do the query. So what sort of context we have passed to the LLM. So we can get all these document names or document, we could say document ID, so that we can correctly identify which document has been used for the answer generation. So there are some sort of metadata which is generation from the document when we are doing the retrieval. So it's a way of like how you could improve it further. So all these metadata can be retrieved from all our documents. So it's a matter of like how you store it and retrieve.
Okay. And Earlier, Arka, you were mentioning about we should use the AI more responsibly. So even if we are able to paraphrase or the AI is giving a paraphrase answer to what we're asking, still it is not accepted in the academics largely as far as my knowledge goes, that it still is an AI generated answer. So what for both of you, Deshan and Arka, still it is an AI. We have not put our mind. Our life has become so easy, so we have not thought about of paraphrasing and then putting in our own words. So that particular skill set is lost if we continue using AI. Am I wrong, right, or is there something else?
So,
Yeah,
as per my view, it is uh, like we should use it as a tool responsibly. What I mean by that is we should own the content it is showing to us, right? We shouldn't just blindly copy paste it in our research and claim it as our contribution. Rather, we should understand it, we should interpret it. Like most of the time, what model like a LLM model does it. So it's a language model. We have to understand what do we understand by a language model. So generally, it is based on a theory of hallucination. Like it understand different things. It tries to interpret it in a most language appropriate manner. So
correct.
what I mean by that is, like, you need to first understand the output. Like, it is just making your life easier, but not creating anything. It is not synthesizing stuffs for you. So what you need to do as a human is you need to understand the nuances of that answer, and you need to own it once you understand and you feel that okay, your views are well represented in those words, or let's say you agree to the things. So for example, we were like for the last decades we were doing Google search, for example. So never in the paper we mentioned that okay, we did a Google search in order to find this kind of sources or this kind of literature. So I mean, we use Google as a tool, but we never, like acknowledged it, or never like referred to that as a thing. So I don't know like why people feel guilty of using a AI tool in the research. I mean, we should not feel guilty about it. Rather, we should acknowledge it in a way that okay, these are the things which were done by AI, and this is how, like, uh, I mean, this part, I mean to say, like research is a long process, right? I mean, which part of that process was done by AI, and what do we and why did we use AI for doing that part, and how are we doing it efficiently? I mean, if you see, like recently in Kai Play, the guidelines in Kai Play for writing papers, uh, it clearly mentioned that how can we use a LLM, or how can we use a AI model to write a paper. Or if you hear the podcast by Professor Linat Nake, we can understand like how to use it more in a way which could be appropriate for a researcher or for an academician. Okay,
Yeah,
so
that's pretty much correct. Like when we are using a tool, we don't require to totally depend on the tool. It's these sort of tools are like sort of like helping you to extract the knowledge. Then the way you apply it, it's totally based on you. The way you summarize all these things, the way you understand about the factors what you have extracted from the data, then how you apply it to your particular domain, it's totally depend on you, the way you use it. So I could say it is not required to totally depend on this application, but you could make your life easy by using these tools in your academic journey, I could say.
And when you were talking about hallucination, is there any theory of hallucination as such in the literature or something?
there are a few. We could refer that in the description section of this video. Like for example, if we also force the GPT model to like come up with some sources. Like it will come up with some random sources.
Correct.
Like, I mean, if I tell them, okay, quote some or refer some Indian authors who are talking about this thing or who have researched about this thing. So it will give you random names like Mishra et al., Gupta et al., or some random authors. So just because we are forcing it to give, right? I mean, it. So another problem with this kind of prompting is, like, internally in the backend, how it works is, like it gives you a probability to things, but while answering it do not gives you a confidence level of how confident is the model in answering that query to you. I think that thing is very essential for a researcher to understand. Not everything which is spoke out by LLMs, I mean, there are not 100% confidence in what they speak out. That is
Yes.
what I mean by hallucination.
Yeah, I'll add one point to that. As I mentioned before, so all these large language models are trained for the network predictions. So it's all these unsupervised data has been trained. All the base models has trained using the unsupervised data, and it's sort of like doing the purpose of like network prediction. Then obviously when we do a prompting and when we ask a data which is like not relevant to his knowledge or what is not being trained, then obviously hallucination is a one factor because you try to generate the next word. If it is not correctly cannot be done the generation of the correct data, then obviously it will generate you the wrong